The reason why that coordinate grid is so important is because it's going to allow us to graph solutions of equations. That's really what a graph is. It's solutions of equations. The most common equation that we graph is a linear equation, otherwise known as lines. Lots of different ways to graph lines. You've learned how to create a table of values, possibly called a T-chart in high school. We're going to look at intercepts, but usually the most popular way is the slope and the y-intercept. Most of my students remember y equals mx plus b from high school, and we are going to discuss that. But let's first of all, how are you going to know if the graph is going to be a line? Before you start out, that's a big part of algebra, is to look at an equation and say, I know what that's going to make on a graph. Well, it's a line if you have no more than two variables. You could just have one, and those variables can only be to the first degree. They can't have, okay, you cannot have a square root, you can't have a squared, you can't have something else really up there. The exponent on the variable has to be a 1. Now again, you don't have to have both x and y, you have to have at least one of those. All right, so which one of these are a line? Well, this one has an x squared. Is that a line? This one has a y and an x. They're both to the first degree. Is this a line? Well, here, now that could be tricky. That's the first degree. That looks like a first degree, but you see that square root? That is not a line. Here we don't have a y, but we do have an x. It's to the first degree. So yes, that is a line. What about that one? And the last one. So very important to know kind of what equation you're dealing with. Now we're going to look at how to graph the line. Again, we have many options. We can create a T-chart, table of values, things like that. All right, so let's kind of go through two different ways. Let's first of all create a T-chart, and you can pick any values you want. You only need 2 points to make a line. 3 is always better. But you know, the first thing I'm going to do here is I'm going to get this y by itself. So how can I move that 3x to the other side? I can subtract it. Now you don't have to do that, but it certainly makes plugging in your numbers for x a whole bunch easier. Right? So I'm going to plug in maybe 0, 1, and 2 for x. So how do I do that? I'm going to have y equals 6 minus 3 times 0 because I chose 0. Now I'm going to plug in 1. Y equals 6 minus 3 times 1. Oops, and I see a mistake already. 6 minus 3 times 0, which is 0, that's 6. And now when I plug in 1, I get 3. And if I plug in 2, 6 minus 3 times 2 is 6, which is 0. All right? So I have 3 ordered pairs. So let's plot those. 0, 6. 1, 2, 3, 4, 5, 6. 1, 3. And again, that's enough to make this line, but let's just do one more. All right, and you always want to use a straight edge and graph paper. And I will tell you that on the computer, it's sometimes very difficult for me to make a straight line. But that one's pretty good. Now, another thing I want you to notice is that it crossed the y-axis at 6 and it crossed the x-axis at 2. Those are called intercepts. Intercepts where the graph crosses the two axes. Let's look at this one. Now this one might not be as easy to solve for y. Well, you could. Let's see, I could subtract the 5x, and then I would divide by -2, and a negative over a negative would be a positive. And that's okay, but most of my students really don't like those fractions. So what could you do if you just started out with that? One option is do the easiest math possible. Let x equal to 0 and let y equal to 0. One at a time. So I have 5 times 0 minus 2y equals 0. What's that going to do? Well, if I divide by -2, y is going to be 0. So if I let y be 0, x is going to be 0. So that's not going to give me another point. Well, again, you could just, at random, plug in values for x. But let me tell you the advantage of solving for y. Even though you have a fraction there, it kind of helps you decide what you should let x equal to. If you don't want to deal with fractions, think about, I'm going to have to divide by 2, so maybe I should choose an even number. What if I let x equal to 2? So y equals 5/2 times 2. Now remember that's 2 over 1. Do you see how the 2's cancel? That's a very convenient little trick. We could have also let y equal to -2. If I stick a negative in there, that would leave -1, and I would have a -5. So let's plot those 3 points. So looking at these two examples, graphing a line, you could solve for y, and maybe you remember about mx plus b. If you don't, we're going to get that in another lesson. You can just arbitrarily make a table of values and solve and plug in some numbers for x. Really practice solving for y. All right, so what if we don't have a linear equation? What happens when we have an x squared and y is not, like these 4 examples? Notice the x is squared. Well, I've graphed all of these for you, and what these are called are parabolas. Y equals x squared plus 1 is the blue one. Y equals x squared plus 4 is the red one. The x squared minus 2 is the green one. And the last one, which I guess is kind of orange, is down here. Now I want you to look at those graphs. They all pretty much look the same, but what has these numbers done to that graph? Well, plus 1, look at there, I'm at 1. Plus 4, I'm here. Minus 2, minus 5. So all those parabolas are going to be pretty much shaped the same way. Notice they're also symmetric with respect to the y-axis, meaning they're the same on the right as they are on the left. So how would we have to graph something like that? But let's hold on. Let's see what happens if I flip them upside down. Well, what has caused them to flip upside down is this negative sign. This negative sign. The negative is in front of the x, so it makes it flip upside down. All right, so let's go through and look at these numbers. So I have a positive 2. I bet that's the blue one. This number is a positive 4. That's the red graph. Minus 3. Which color do you think it is? Green. And the minus 5 is the orange one. So if you have an x squared, you're going to have a parabola that points up, like a smiley face. But if you have a negative x squared, it's going to go down like a frown. But all these parabolas are again symmetric. Most of these are going to be symmetric with respect to the y-axis. Right, so knowing these things, we should now know this is not a line, and it's a parabola, and it's going to go up. But we need more than 1 or 2 points. We need like 3. Now, if you remember, it's symmetric. So let's just pick 0, 1, 2, and we need some negative numbers as well. All right, so we can get that whole kind of happy face. All right, so if I plug in 0, I'm going to get 2. Which makes sense, that plus 2 should move it up. If I plug in 1, I get 3. If I plug in 2, let's see, 4 plus 2 is 6. What happens if I plug in negative 2? Well, I need to be careful. I'm going to have negative, I'm going to square that. That still is positive 4 plus 2, which is positive 6, which makes sense because it's symmetric. All right, so what do you think I'm going to happen when I plug in negative 1? You're right, it's going to be the same thing as positive 1. And then if you connect those, you're going to have your pretty little smiley face parabola. On this one, going to be a parabola again, not a line because of the x squared. And because the negative is in front of the x squared, I know it's going to go down. But let's plug in those same numbers, 0, 1, 2, negative 2, negative 1. We need to be really careful with our signs. So we have 3 minus 0 squared, which is 3. 3 minus 1 squared. 3 minus 2 squared. So that's 3 minus 4, which is a negative 1. Now, what's going to happen when we do a negative 2? If I plug in a negative 2, do you see I'm going to square that first because that's order of operations, I'm going to get the same exact thing as I got with positive 2. Same thing with the negative 1. And again, there's that symmetry. All right, what happens when the y is squared and x is not? Well, we get a parabola, but it's on its side. So let's look at these. We have y squared plus 2, and we have y squared minus 4. Which color is which? The plus 2, the x is plus 2, that's the blue one, and the minus 4 is the red one. Now notice this time that we have the minus in front of the y squared, and that makes it go to the left. When the y squared is positive, it goes to the right. So let's see if we can match it up. There's a 3, there's a 6. We have purple and orange. This is the 3, this is the 6. So we have purple and orange. Now notice this is also symmetric with respect to the x-axis this time. How could we graph that? Well, this time, since x is solved for, we're still going to do a t-chart, but instead of choosing numbers for x, which we could do, that's a little bit harder, is let's choose numbers for y. All right, let's kind of come up here and let's look at these pictures. All right, let's see. On this one, what was y? I had a y value of a 1, and maybe a y value of a 2, and a y value of -1, and a y value of -2. Hopefully those sound familiar. So because x is by itself, I'm going to plug in the same numbers I plugged in a while ago, but I'm going to do it for y. All right, so I have x equals 0 squared plus 3. X equals 1 squared plus 3. X equals 2 squared plus 3. All right, so if I plot those points, and then if I plug in -1 and -2, notice you get the same thing. So those are going to match, and these are going to match. And they're not V's, they need to be kind of rounded. Same thing over here. All right, so I have x equals 1 minus 0 squared, x equals 1 minus 1 squared. All right, we have x equals 1 minus 2 squared. Notice it's going to the left, and then by symmetry we know what the other two dots are. Oops, not very good, but close enough. So again, if I plug in -1, I'm going to get the same thing, as +1, which is 0. And if I plug in -2, I'm going to get the same thing there. All right, so it's kind of nice to know what happens when you have one thing is squared. They are parabolas. Now we have a square root sign. Look at that. Almost the same as what we just had, except that it's a half a parabola. So here, if you want to think about that as being plus 0, y equals the square root of x. And then we have plus 4. This is at 3, this is at -1, this is at -4. This is where it gets interesting. This is the red one, this is the green one. Notice plus 4 means go to the left, -3 means go to the right. A tad bit confusing. And this is the orange one. Now because there's a square root, when we choose values of x, we have to be very careful. We cannot have the square root of negative numbers. All right, so let's look at this blue graph right here. The reason why it's halfway is because what can x be? X was 0, x can be 1, 2, but notice x cannot be any negative numbers. So as we graph this one, I want you to think about what's the smallest thing I can let x equal to. In other words, the smallest thing this expression can be is 0. So if I solve for x, -3 is the smallest thing x can be. And then we want to go bigger than -3. Now remember, bigger than -3 is like -2, -1, 0, in that direction. All right, so let's see what's going to happen. When I plug in -3, I'm going to get the square root of 0, which is 0. And then when I plug in -2, I'm going to get the square root of 1, which is 1. And then we have to kind of say, well, If I plug in -1 plus 3, ooh, that's the square root of 2. Let me try if I can do something else. What if I plug in 0? That's not bad. But what if I plug in 1? Ah, that's the square root of 4, which is 2. And I know that one. So let's just skip down to that one. And there's my half a parabola. So here you might want to choose some numbers where you can get like the square root of 0 and the square root of 1 and the square root of 4. So again, what's the smallest that can be is 0. So if I solve for x, the smallest value of x could be 2, and then I want to go bigger. So I'm going to have y equals the square root of 2 minus 2, which is 0. Y equals the square root of 3 minus 2, which is the square root of 1 is 1. And then just like over here, I kind of want to say, well, what could I subtract minus 2 to get like the square root of 4? I think 6. 6 minus 2 is 4. The square root of 4 is 2. So let's plot those 3 points. And again, we have that sideways half parabola, if you will. So you need to be able to identify graphs. Are they lines? Are they parabolas that go up and down? Are they parabolas that go side to side? Or are they that half parabola?